Hey guys, welcome back to another tutorial. This time I want to do some refactoring. I also want to do like make the sun move to have like a day-night cycle kind of thing. But basically, fundamentally, this tutorial is going to be about refactoring. The thing I want to achieve in this tutorial is to have something like what I'm going to show you now, which is something like this, where I have what we already had, the solar panel acquiring energy from the sun, and the sun is rotating, and as soon as the shade hits, the solar panel stops producing. And I also want to refactor all the code just so I can make stuff like this. I can create other types of energy generators, in this case like a kind of a wave based generator, which is also charging this battery, and it doesn't depend on the sun because obviously it's wave powered. So, and this refactoring is going to open the way to have more types of energy generation devices in a more generic way. So let's get started. So this is the code that we had, or the blueprints that we had from the previous tutorial. We had our fantastic solar panel here, and the sun is not moving, and the text is a bit different. I should reduce the font size. Okay, let's begin with that. Let's just reduce the font size on this guy because I don't really like it like this. It's kind of annoying me. So font, and let's make it maybe 16, I don't know. Let's give it a try. Slightly better, maybe 14. Yeah, that's fine. Cool. Oh, and we also changed the color on the text and not on the... Yeah, let's reset this binding here. Actually, let me select the progress bar. Then I'm going to fill color and opacity. I'm going to bind it to the other one, and I will remove the binding from the text. And this way, it should be the bar and not the text that has the proper color. So green when it's full, red when it's not, when it's completely empty, and then shades of yellowish to green as it moves along. So that's for the first small change we want to do. Now, another thing I don't like about this is that I am referencing the directional light, or in the sun in this case, by name. I don't really like that. So the first thing I'm going to do actually is to move the sun to its own blueprint. You know what? Let me just create the new folder here. Let's call it tutorial 6 refactor and wave power. So the first thing I'm going to do here, I'm going to create a new blueprint. I'm going to make it derive from directional light. I want to make like a special kind of directional light, which is the sun. And the sun is going to do all the calculations for the position and all that, and the rotation, the day-night cycle and all that stuff is going to be controlled by the sun itself, which is much prettier than you know, having another blueprint doing that calculation for us. It's always nasty, and you should always strive for having like the code properly compartmentalized, like delegation of responsibilities, so the sun basically manages its own state and its own operations and all that, and there's nothing external moving it basically. The only thing we should reference from the sun is basically getting the current position of the sun so we can calculate the rays for the solar panel, but otherwise the sun should be responsible for its own thing. So let's see, we're gonna need a couple of variables here, actually around 4 variables. We need the current location. This is the thing that we're going to reference from the outside, and it's going to be a vector. We also need the rotation speeds. We want to be able to control at which speed the sun moves in the sky. I'm not going to do this completely realistic. What I'm going to do now is I'm just going to set it to 5 maybe. And yeah, if we wanted, we could set it to a more realistic value based on the actual speed of rotation around the rotation of the Earth on itself. But let's not do that. Let's just put 5, which is a nice value. Let's set the current rotation to 180. So the sun starts up in the sky. And now I need, I also need something. I need the reference to the sky sphere, sorry, because that's the way we control the actual disk in the sky. Otherwise, only the light moves and the disk stays on the same place. And that is actually controlled inside the, let me see, inside the BP sky sphere. Yes, that we have on our scene. And it can be seen here. It's actually this, if I can find it. Sky sphere blueprint. This guy here. So this guy controls the actual disk in the sky. So we need a reference to it so we can, change it as the light changes as well. So first thing I'm going to do, I'm going to set the reference to this sky sphere. I'm going to get all actors of class BP sky sphere. Yes, on begin play, I just want to get a reference to this, and I'm going to set this to the first value that is here on this array. It should be just 1, so I'm just being lazy and setting it here. Now on event tick, the sun needs to move. So the thing we're going to do is just add a small rotation every tick based on the delta seconds and the rotation speed. So I'm going to need the rotation speed. I'm going to multiply delta seconds by the rotation speed. So I get like a really tiny rotation per frame. And then from this, I'm going to make a rotation from axis. Sorry, my mistake. Make a rotator. Only make a rotator because I want to be able to change the pitch value. And I don't need this. And then I am going to add actor local rotation. So I'm just going to increment the rotation of the sun by a tiny bit each frame based on the speed that we are defining. And then I'm going to call a function called calculate location, which I'm going to create now. Calculate rotation. And this function is actually going to be really simple. It's just going to get actor rotation. I'm going to get the forward vector. This is basically what we were already doing on the other blueprint previously to calculate the sun position or rotation. Sorry, I called it rotation. It's actually position or location. Let's call it location. The location of the sun. And I'm going to multiply this by a very big number. So we trace the line to very high in the sky. Let's say 1 million. And then I'm going to set the current location of the sun to this awesome value that we calculated. Done. And finally, I want to update the sun location on the sky sphere. So I want to, there's a special method for this called update sun direction, and it will just take into account the direction light automatically that is on the scene. So yeah, we just need to replace the sun by our own sun, and that's it. So one thing I want to do now is just, let's put the sun here. I am going to take a look at our current sun, and I'm going to just replicate the whole thing. So I'm going to copy the location and paste it on the sun. I'm going to copy the rotation, paste it on the sun, even though we are overriding it a little bit. On begin play, I am going to, the scale should be okay. I'm just going to copy the intensity, and I think that should be it. Make the intensity, and I'll remove the current sun, and that's it. So now I need to in the BP solar panel or the solar cells component, I think. Yes, find sun location. So I'm not going to need this anymore, or I am actually going to change this a little bit. Let's see. I need to I am going to set the reference not to the sun location. Well, I might set it to the sun location. I might store the sun location as well. See if I need it. I don't think I need it. Yeah, I don't need it anymore. So I'm just going to set a reference to the sun itself. And it's going to be BP sun. This is our sun. So now I will change this variable, this function to find the sun, which is always fun. And this find sun is just going to, well, I don't need any of this here. This is just to calculate the position and all that. I don't need this anymore. I am just going to get all actors of class BP sun, and this time I don't need to do anything by name or iterate or anything. I already know that I only have one sun in the scene, so I am going to get 0, and I'm going to do a set like I did before. Oh, and that's it. We have our sun. We have our sun, and since we already have our sun, what do? We go to the calculate cell power, which is here, and we had the sun location here. We don't need it anymore because we can just do get sun, get current position, which is our own method that already knows, well, it's not a method, it's actually an accessor to a variable that we update on tick, and we just, replace this with the sun location. I'm just going to copy and paste this and replace it here as well. We're tracing the debug lines, and just make this a bit neater, kind of ish. And now I shouldn't need the sun location, so I'm just going to delete it. Let's see if this works. So I don't see anything moving. And I don't see the sun as well. What could be wrong here? I think this is going to show me. Yeah, I'm trying to change the rotation of the sun, but the sun is actually not movable. So I need to go to the BP sun and make it movable here. And that should make it move, I think. But I see, well, yeah, I can see it moving now. But I still have some problems here. So update sun direction. I am probably passing null here. Yeah, access none. Read property directional light actor. Oh, I need to go. I thought it would detect it automatically, but I actually need to go to the sky sphere and tell it which light is the sun. Yeah, because otherwise it has no idea. So now, as we can see, the sun is moving and the light should be moving as well. And, we just don't see any debug lights, which is kind of strange. So I probably made a mistake while calculating the sun direction. Let me just take a look if I made any mistakes. Oh, that's not what the problem is. Oh, let's see. Let's open the sun and let's take a look. So we are taking the sky sphere, we're starting the sky sphere, and then on each tick we are taking the rotation speed, which is actually 5. We are multiplying by the delta seconds, making that into a pitch rotation, adding that to the local rotation of the actor, Oh, we're not calling calculate location. We need to call this function first. We need to calculate our location so we can pass it outside. And that's why it wasn't showing the location. Okay, now we see everything and it's properly working, and it stops being in the shade, and the solar panel loses power, and all is good. Cool. That's the sun part. Now, a couple of other things I don't like about this code or this set of blueprints right now is that I can't easily extend this to different types of power sources because it's very interconnected with the solar power generation thing. And I would prefer to have this in actual components. The code, I would prefer to have like the energy production component. It's a component that generates energy, and from which then we could derive solar power generators and wave power generators, and they would know how to specifically calculate the kind of power that they wanted. The solar panel would do it by the cells on the panel. The wave power could do it based on a force being applied on the water. Let's say a wind generator could do it from the force of the winds. And another thing I would like as well would be to have like a container component, an energy container component, that I could apply to any type of vectors and make them accept energy and store energy, basically. So let's do that. Let's create a couple of components. Let's create, because this BPI energy receiver is nice, it has the receive power, but if we look at the code that we implement on the battery, for instance, the receive power, let's see, solar, oh, it's actually an event, sorry. The receive power, this is pretty much the same for all kind of battery-ish devices that we might want to have. So I don't want to have to, rewrite this whole thing every time I have a new type of battery or whatever. So it makes more sense as a component than an interface. So that's what we're going to do. We're going to create a new blueprint class. I'm going to say it's an actor component, and I'm going to call it BP. Should I name it BP? I'll probably just rename it. Let me see what I call it on the other projects. Yeah, I didn't call it BP. Maybe I should, but let's just call it energy container component. Okay, energy container component. This is going to be the container that is responsible for storing energy. And it's going to be actually pretty simple. It's going to have two variables. One is the current energy that this container possesses, and another one is the maximum amount of energy that this container can have. And then it's going to have the function that we had declared on the interface, but we're going to actually implement it here, the receive energy function. And the receive energy function just accepts one input, which is going to be the energy that we are receiving. And it's going to be of type float. And this is only going to do one thing, adding to the current energy that we have and clamp the value. Let's set the default for the max energy to be 1000 for all energy containers, and let's get our current energy here. Let's add this to, let's add the energy that we are receiving to the current energy, and then let's clamp this value to be between 0 and the max energy, because we never want this container to have more than the max energy. And then we just set the current energy to the value that we get from the clamp, and that's it. That's basically the energy. That's basically the energy container component. So now, what we can do is we can go to our battery. I don't know why this keeps messing this thing. Okay, we can go to our battery and our event graph is actually going to become much more simple because the only thing we're doing here is setting up the power bar with the UI. Yeah, and we don't need any of this now because if we remove this, we go to class settings and we remove the BPI energy receiver from here. We are no longer an energy receiver, but we are going to add a component called energy container component. And this guy is actually going to be responsible for storing our energy. Now, this is not going to work immediately because we need to do a couple of changes. So one of the things we need to change is the way we tell the widget our energy levels. It's not going to be this max capacity. Actually, I'm going to just remove these guys because I don't need them anymore. These variables are useless now. And the way basically our power, we're going to get it from the energy container component. And we're just going to say for max power, we're going to get max energy. I should just standardize these power energy kind of namings, but you can do it if you want. And this one is going to be the same. We're just going to get the energy container and get current energy and return that. Fine. But now if we run, the batteries will not be charging because the components are not getting the energy because we were assuming one thing and we have another situation now. So what we need to do is we need to go to the BP, let's say, I think the solar panel was responsible for this, maybe? Yes, distribute power. Okay, so we are basically, we have our energy receivers registered and we are sending them power, but this will no longer work because the energy receivers no longer implement the BPI energy receiver. Instead, what they do is they have the energy container component. And I don't want to do this right now. I'm not going to make this change now because I have other more profound changes to do. And the more profound thing I need to do is to change this BP solar cells component to be derived from an energy production or let's say, yeah, an energy production component. And let's see, the way I'm going to do this is I'm going to create an energy production component, which is going to be basically abstract. I will not let anyone implement this. It means you need to create a derived blueprint from it and specify exactly how it produces energy. So I'll just create a blueprint class. I will make it an actor component, BP, oh, actually, no. Let's just call it energy production component. And let's see what we need here. We need a couple of variables. We need energy production, which is going to be the value of the amount of energy that we are producing. And we want to have our receivers. So this component is actually going to be responsible for handling the receivers of energy, and hence delegating this away from the actor, which is much neater. So let's just call them receivers here, and I need to make it of type energy container component, and it's going to be an array. So we store directly the reference to the components themselves, which makes it much easier. And on begin play, just for the sake of it, I am going to clear this array just to make sure we start with a clean slate. And on tick, I'm going to call a function called produce energy, and this function is going to receive the delta seconds because I want to produce only a tiny fraction each frame. You know the drill. And I'm just going to create this connection right now so we don't forget. So that's it. So every tick, the energy production component produces energy. Makes sense, right? The produce energy method is going to be similar to what we already had on the solar panel. So we are going to take our energy production. Let's see, we're going to take our energy production. We are going to divide this by 3,600 because we want to know this. We are saying that our energy production is basically per second. And I'm going to leave it 0 for now, but we are going to change this in the derived classes. So per second, I need to divide this value by 60 minutes and 60 hours, 60 minutes. And then I'm going to multiply this by the delta seconds because I only want a tiny fraction of this value. And I am going to divide this by the number of receivers that we have, because I only want to I want to distribute the charge by all receivers and not give the same charge, well, not the full charge to all receivers, which makes sense. And I divide this by the number of receivers. So I have the tiny amount I'm going to send each receiver. And I'm going to create a local variable for this called p energy per receiver. It's not going to be an array, and it's going to be a float. And I'm going to set this value here. This is the tiny amount I'm going to send each receiver. After this, what I'm going to do, this is just to facilitate not having a bunch of lines all over the place, all over the blueprint. It just makes it a bit neater. I'm just going to get the receivers. I'm going to iterate this guy, and for each of them I am going to call receive energy, which is a function that we already implemented on the energy containers. And now I just plug this here, and this is just so I don't have to move this. Actually, I don't need this, to be honest. Let's just get rid of it because I'm only using it in one place. I don't really need it. Let's just make it neater with one of these. Fine. Cool. So every second we are generating a little bit of energy. Now we need a couple of other functions. One to add a new receiver to us. Let's just create a new function called add receiver. This add receiver is going to accept a receiver from the type energy container component. We want to add a new receiver to our list. First thing I want to do, I want to check if it's valid. It's always a good check to do if it's not null, basically. And if it is valid, I am going to get my receivers and I'm going to do add unique, so I never have a copy of any receiver in my list. And then I am going to I'm just going to print a string, and I am going to create an append node here so I can just read what am I adding to the receivers. Added, and then this is going here, and I'm just going to get the display name from this guy and add it here. So every time we add a new receiver, we see a message saying I added the new receiver and which receiver. And I'm going to add a new function called remove receiver, which, as you might have guessed, is going to do the exact opposite. It's going to take a receiver. I'm going to get the receivers, and I'm going to do a remove item, and I pass on the receiver that we get. And here it doesn't really matter if it doesn't exist or if it's invalid or whatever, it's just going to ignore it. So it's fine to do it like this, I believe. So I think we're ready on this part. The energy production component is okay now, and we can basically go to our solar panel. Well, one thing I don't need anymore is this BPI energy receiver. It says it's still used on the BP solar panel. Yeah, but that's just because we're going to change it on the solar panel anyways. So I'm going to delete it right now. It doesn't crash the editor. Didn't. So now I'm going to open the BP solar generator. And let's see. Oh, I want to do another thing first. I want to create a generic class to hold the generic code basically of handling the intersection. You see this sphere that I'm using to see the radius of the energy production. Basically, I want that to be generic as well, because if I want to have more than one type of energy producing thing, I want the power bar and the energy provider radius to be generic and be on a base class basically. And so we're going to create that base class. I'm going to make it here on the tutorial 6. So I'm going to create a new blueprint class called, it's going to be an actor, and it's going to be called BP generator. So it's a generic generator, and I have a typo there. Generator, if I can type. So this BP generator is going to have two things. One, a sphere collision, which I'm going to name energy production radius. This is going to control the radius on which we add and remove new receivers. This is going to be 100, and it's going to ignore, I need to set it to ignore the light, because otherwise it's going to block the solar panel from getting light from the sun. And the other thing I need is energy, I need a widget, and I'm going to call it energy information widget. I'm just going to attach it to the root node as well. This guy is going to have, let's see, it's going to have here, I need it to be screen. It's going to be 50 by 10, which is similar to the ones we have, and it's going to be a power bar. Cool. So now what do I need here? So I need a lot of stuff on this component. This component, we're going to handle all the adding and removing of receivers, setting up the UI, and setting up the initial receivers, all stuff that we're doing on the solar panel, and we don't want to do any more there. It's also going to be it's going to have to implement the, let's go to class settings. It's going to have to implement the BP energy, what did I call that? BPI energy information. So we get these two functions that we need to implement to know the information on the widget. And let's see, variables. What do I need here? I don't really need anything other than maybe I do. Let's see. I am going to need at least the energy production component reference. So I'm going to add that in, energy production component, energy production component reference. And then what I'm going to do here is, let's see, I need to get it automatically from the actor. And I'm going to do that on event begin play. I'm just going to create a function to do that. Set up energy generator component. And in this function, I am just going to get components by class, and I'm going to get a component that is on the same actor or derived actor on this, and it's going to be energy production component. And I'm going to set this to be this guy. So as long as the actor contains one of these, we should be fine. And now I'm going to call this function on begin play, just so I get a reference to it. Next up, I want to do a setup UI, basically what we were already doing in the solar panel. I think I'm just going to copy this from the solar panel. Instead of power bar here, it's going to be a different thing, but it doesn't really matter. It has no power bar, but it's the energy information widget. We just set it to this, and this should be fine. Since this class implements the BPI energy information, this is all going to work. So, and I just call setup UI next. Another thing I want to do is another function called setup energy receivers. This is going to be really similar as well to the one on that we have there already, that we're not going to use anymore. And I am going to get the energy production radius. I am going to get overlapping actors. All of them. I don't care. I will just iterate this for each loop. There you go. And from each of these actors, I'm going to get component by class. And if this guy has an energy component, energy container component, means it's a potential receiver, right? And then if that happens, I'm just going to get the energy production component and I'm going to add the receiver. And which receiver I'm going to add? This guy. There you go. There you go. So this is setting up the initial receivers in the case we have a world that already starts with some receivers inside the radius. And now we need to handle the cases where we add dynamically, where we add receivers and remove receivers. So I am going to the energy production radius. I'm going to override this guy and I'm going to override, oh, not this guy. Oh, this guy. And I'm going to override this guy. So begin overlap. Oh, not the hit. Damn. I don't like it when I can't read this thing. So this is hit, this is begin overlap, this is stopped overlap, end overlap. Okay, this is what I want to override. Cool. And let's see, what do I want to do here? I want to get the other actor and I want to get component by class. Same thing, you might have guessed it by now. Energy container. If this guy that is overlapping has an energy container on it, I will get the energy production component. And I'm going to call add receiver with this value. There we go. Similarly, if this guy, if this guy has that stops overlapping with us, if it does have a component by class called a component called energy container, then we want to do remove receiver, and we try to remove this component from it. And that's it. Cool. What else are we missing? I think I'm still missing something here, but I will see. Oh, of course, we're missing this. But we're not going to implement it because this is going to be, well, we could implement it here actually. Ah, okay. Let's implement it here because we already know that we have the energy production here, right? And we could just get the max. Oh, we can't, wait. Because the energy production component, oh, we can't do it here. Okay, let's leave it for later. So we have the event graph properly ready. So now all we need to do is go to the solar let's go to the solar panel, and I am actually going to rename this guy to BP solar generator. Just for completion, BP solar generator. And this guy is full of errors now, mainly because we don't need a lot of stuff here. Let's see. So I don't need all these variables anymore. I just need this guy to inherit from BP generator. I think it's going to complain about the interface. Yes, reparent. I'm just going to remove the BPI energy interface. I don't want this to be part of my blueprint. And okay, I'm going to move all this code to another component. And I think I'm going to do it right now before touching the solar panel. I'm going to create, let's see, I think I already have, yeah, we have the BP solar cells component. I'm actually going to rename this guy to solar cell energy production. Yeah. Solar cell energy production. And I'm actually going to, okay, we did the define sun here. We did this change. We need to do some more changes. And the first thing I'm going to do is I'm going to reparent this guy to the energy production component. So it's going to be a child of energy production component, which already does a bunch of stuff for us, namely handling the receivers and all of that stuff. So one thing I need to do here is I need to call the parent function now on both of these guys. The begin play I'm going to do before, so I call the parent, which means that if we take a look at our let's see, if we take a look at our energy production component, we have on the begin play we have this clear for the receivers, and I want to do this for obviously for any derived classes, so I'm going to call the begin play on the parent. Then we do define sun, then we do define cells in actor, then we calculate the max power. That is all okay. The event tick, we do we calculate the generated power. That's fine. We need to set the energy production. Basically, we're going to change the value of the parent. We don't need this. I'll just get rid of it. So we need to set energy production on the parent, because the parent handles all the energy distribution now. And so this means we need to change this calculate generated power a little bit. I'm going to add an output called generated energy here. And it's going to be a Boolean. And this is what we're going to set the energy production to. And then I'm going to call the parent on the tick afterwards, which is actually going to distribute this energy that we just calculated. And I need the delta seconds to do that, so I will pass it on here. Neat and clean. Cool. Now I need to go to the calculate generated power, because this is currently not returning the power. And there's a bunch of variables that I don't need here. Namely, let's see, or maybe I need them all actually. So I need the generated power per cell because it's calculated there. I need the cheating factor. I need the max power, but I don't need the generated power. Yes, I don't need this guy. I'm just going to delete it. And I think I'm going to keep all of this or most of this. Let's see. Yeah, I'm going to keep all of this. I'm going to keep adding the power to the... Yeah, I don't need this guy. I'm going to keep adding all the power to the temporary variable, and then I'm going to call the return node, which is actually wrong here. Generated energy, name generated energy, doesn't match any parameters of function, calculate generated. Oh, there's something wrong here. What is wrong here? Calculate generated power. Oh, because I added there, but I didn't add here. Generated energy. Oh, I can't do it now. Let's leave it param, and I'm actually going to do this. It's kind of a crappy thing that we need to do sometime. Energy, generated energy. Cool. And I'm going to set this, when I finish the loop, I'm going to set this as the return nodes, and I will return the calculated energy, so I didn't need to store it anymore. And this is being passed to the energy production on the parent, and then the parent distributes to the power. Cool. Sounds good. There's one thing I don't need here, I think. I need find the sun, find the cells in actor. I need calculate the max power because it takes into consideration the cells. I need calculate generated power. I need calculate cell power, but I don't need this display generated power because we have the UI for that now. Cool, the solar cell energy production is done, meaning that I can go to the BP solar generator and I can add it here, which means I don't need most of this now. That's so cool. I'm just going to add the BP, so the solar cell energy production. Yes, cool. What do I need here? What else? Let's see. I don't think I need any of this, to be honest, because the UI is set up by the solar cell energy production. The receivers is handled by the energy production, so I don't need begin play. I don't need begin overlap. Distributing the power is the responsibility of the solar cell energy production. I don't need it. And controlling the adding and removing of receivers, also the responsibility of the energy production. I don't need it. Meaning that I don't need to set up the UI. I don't need to set up energy receivers, not add energy receiver, distribute power, calculate. I don't need any of this, which is fantastic. All I need to do is specify how we display our power. And we already have that. We already have that? No, it's wrong. It's this guy now. The solar cell energy production. Actually, I'm going to delete the power bar because we have the energy information widget, and I'm going to remove the energy provider radius because we have the energy production radius, which is inherited. So gone. And I don't need the BP solar cells component anymore. Actually, did I make a mistake here? BP. Oh, we don't have it anymore. Why is it there still with the same name? That's the same thing. Oh, I had both. Okay, let's keep the other one. It has a neater name now. And I also need to change this in the current, yeah, here. Okay, this guy as well. Generated power. I still have errors though. Oh, get current. No. Get max power. This guy has max power. Why doesn't it have current power? Get current power? It's a message. It's kind of strange. Oh, it's called energy production now. Get energy production. Yes. It's the energy we are producing. Let's see. What else do we need? I think I might have it. Oh, I don't need the energy receivers anymore here. That's kind of cool. And let's see if it works. I do see this maybe producing stuff, but it's not sending anything to the batteries, and I get some errors. Let's see. Access none, trying to read property. Energy production components on the produce energy. Okay, let's debug this. So the solar panel or the solar generator. Let's take a look at this. Yeah, it's cool. Inherited interfaces, BP generator, that's fine. Oh, do I see adds? Yo, I see added the receivers. So these 4 receivers are being added. It's just not producing any power. Let's take a look at the BP generator. So this is working fine. It's adding the receivers. But then, oh, are we producing any energy? We might be not producing any energy. Let's take a look at the energy production components. Oh, product energy. Wow. What I meant was produce energy. Produce set. Oh my god, I can't type today. Produce energy. Cool. See if that's it. No, that's not it. So produce energy. It's trying to call the produce energy, but it says it doesn't have anything. Okay. Receivers. Energy container component. Yes. And receive energy. Okay, I need to debug this. I do get the 4 registrations. So it means that this guy here, the energy production component, does have them on the receivers. So when we produce energy, let's add a print here, and I'm going to print the amount of power we are generating. So we are generating power. Okay, we are. This is fine. But now here, I think there might be something wrong here. Let me print this guy, to which I'm giving energy. Yeah, there's nothing there. So I wonder, how am I getting receivers that are not valid? Because if I remove this line, I don't get any errors on the, so I'm getting receivers registered that are not valid. Let's see. Add receiver. Is valid, add unique. Oh, I'm not adding anything to it. Haha, I just missed one line. I hate blueprints. Okay, so now we are generating power. All good. We stop having the sun and we stop generating power. So that part is fine. And I think this is going quite long now. I will stop here and make a second video where I continue the refactor and cleanup. And yeah, I'll see you guys next time. Hopefully soon. Bye.